Sometimes we come across questions or equations which look like they are simultaneous equations, but when we try and find their solutions, they become a bit messy. While they can be solved using the methods of both substitution and elimination, and they might become messy, but there's an easier way of solving them. And if you want to learn that easier way, this video talks about some situations just like that. Hey guys, my name is Vikas Sharma and I welcome you all on behalf of Exponent to Success. Exponent to Success is an initiative which helps to add an exponent to your learning curve. If you are a first time visitor or if you are new here, I would suggest you subscribe to our channel right now so that you don't miss out on any future content from us. Well, this video is the last video of our series of simultaneous equations or a system of equations or a pair of linear equations in two variables, and we have already done the graphical method, the elimination method, the substitution method, the cross multiplication method. And if you haven't seen those videos yet, you just click on the top right hand corner of the screen. There's a link there and it will take you to all the videos there. In this video, what we are going to discuss is some typical examples or some weird problems that we come across, which they look like simultaneous equations, but when we try and find their solutions or work out the solutions, they become a little bit messy. They either give us no answer, we get confused, we don't know how to solve it, or they just take the quadratic form. Well, there's an easier method of solving such equations, and if you ever come across these equations, since we'll do a couple of problems here, and if you ever come across equations like these, the best method is to go about the way we solve them in this video. Stay till the end of the video and watch it in full, because you don't want to miss out on any content or any examples which might come, examples similar to the ones that we are solving now, which might come in your exams and you get confused. You might save a couple of minutes, you might save a good 5 minutes, 10 minutes, which in an exam like scenario is too much, and it may be beneficial for you if you learn these methods, and once you remember these, and if they come in your exams, you're going to do very well in them. So here I've got a couple of problems for you. The first problem that we have is 3 upon x plus 5 upon y minus 4, and the second one is 5 over x minus 2 over y is equal to negative 17. Now these equations, they do look like a system of equations, but when we try to solve them, because x and y, the variables, they're both in the denominators, so when we try to solve them, we can do, take the LCM of x and y, which happens to be x, y, and then this becomes 3 times y plus 5 times x. That should be negative 4. We multiply both sides by xy, so this gets cancelled and xy comes here. Now we are familiar with this part of the equation where these are like simultaneous equations or a system of equations, but what about xy? Where did the xy come from? We don't know how to solve equations like those, do we? No, we don't. Well, you can use the substitution method or the elimination method. So in the elimination method, you try and bring the coefficients of one of the variables to be same, then you add or subtract the equations, eliminate one variable, then try and find the value of the other variable. But because these are fractions, it might cause a lot of trouble for you. It might go wrong somewhere. So the best way to do is, what I'm going to do here is I'm going to assume. And what am I going to assume? Let me take my assumptions here. So I will say, let's say that 1 upon x is equal to m and 1 upon y is equal to n. So now we'll rewrite the equation. So 3 upon x is something like 3 into 1 upon x, right? 3 times 1 upon x. So that since 1 upon x is equal to m, we have assumed it to be m. This becomes, the first equation becomes 3m plus 5n is equal to negative 4, and the second equation becomes 5m minus 2n is equal to negative 17. Now I'm going to try, let me call this equation number 1 and this as equation number 2. I'm going to solve them the elimination way. So what I'm going to do is I'll take the LCM of the, I'll try and eliminate n first, since they've got opposite signs, so it will become easier. So I multiply the first equation by 2 and the second equation by 5. And why I'm going to do that is because when I look at the coefficients of n, which are 5 and 2, when I take the lowest common denominator of 5 and 2, it happens to be 10. So we want to make both the coefficients as the lowest common denominator. So to get a value of 10 here, I need to multiply the first equation by 2, and to get a value of 10 here, I need to multiply the second equation by 5. So when I rewrite these equations, they become, so one thing again I told you, when you multiply the full equation right from here to here. Don't miss out the other side of the equal to sign, that's very important. So when I do that, 3m times 2, that becomes 6m, and 5n times 2 becomes 10n, is equal to negative 4 times 2 becomes negative 8. And the second equation, I multiply them, so 5m times 5 becomes 25m, 5 times 2n becomes negative 10n, and negative 17 times 5 becomes negative 85. And then I just add these two equations. Let me call this equation number 3, this is equation number 4. I'm going to add the two equations, because when I do that, the 10n, positive 10n and negative 10n, they get cancelled out. So I've eliminated the variable n. What I'm left with is only n. So it becomes 31 times m. That should give me, that should be equal to negative 93. And when I try to find the value of m, we just say m, so we divide both sides by 31. So 31m divided by 31, we get m, and negative 93 divided by 31 is negative 3. Negative 93, sorry, divided by divided by 31. So 31 goes into 93 3 times, so it becomes negative 3. Once I've got the value of m, I can put it in any of these equations, either 3 or 4, and get the value of n also. So since equation number 3 has got smaller numbers, I would prefer to put into that rather than into the fourth equation, because that has got bigger numbers. So the third equation number 3 is 6 times m, which is negative 3 that we have found out, plus 10n is equal to negative 8. So 6 times negative 3 is negative 18, plus 10n is equal to negative 8. I add 18 to both sides, so this 18 and plus 18 becomes cancelled, and we are left with 10n on the left side, and negative 8 plus 18 gives me 10. I divide both sides by 10 and I get the value of n equals to 1. So I've got m equals to negative 3 and n is equal to negative 1. Let me write it in red here, since that's the solution, but mind you, that's not our full solution as yet. We are going to go further than that. This is just part of the solution that we have, that m is equal to negative 3 and n is equal to negative 1. Now let's go back to the assumptions that we took here. The assumptions were that, let's say that 1 upon x is equal to m and 1 upon y is equal to n. Actually, we didn't want the values of m and n at all. We wanted the values of we wanted the values of x and y, not m and n, because the equations that we were given here contained x and y. They didn't contain m and n. So what we are going to do is that, since m is equal to 1 upon x, x is equal to 1 upon m. So if m is negative 3, therefore x is equal to let let me write here. I'm falling a little short of space, but I don't need this actually. I can rub this off. So that gives us the value of x is equal to 1 upon m, but since m was negative 3, therefore x is equal to negative 1 upon 3. What about y? So we had assumed that 1 upon y is equal to n, or we can say that y is equal to 1 upon n, but the value of n that we had found out was 1, right? So therefore, since y is equal to 1 upon n, therefore y is equal to 1. So the solution that we have is the ordered pair. For x the value is negative 1 upon 3, and for y the value is 1. So that's our solution. You can substitute these values back into x and y and see whether the equation is solved or not. Let's jump on to the second problem. The second problem that we have is something like this, where 133m plus 221n is equal to 929, and 221m plus 133n gives us 841. Now this is a we can solve this by elimination, which means we'll have to make the coefficients the same, which means we'll have to multiply the first equation by 133, and we'll have to multiply the second equation by 221. But can you imagine multiplying 929 by 133 or 841 by 221? Those would become very large numbers, don't you think so? Isn't there an easier solution to this? Well, there is actually, and the way we solve such problems is that what we do is we call this as equation number 1. Let us name them right in the beginning. This is equation number 1, this is equation number 2. So first what I'll do is I'll try and find out what 1 plus 2 gives me. So I'm going to add these equations together, and when I add them, so 133 plus 221 gives me 354m, and when I add these 221 plus 133, that again gives me 354n is equal to, and I'll have to add these two terms also together. So 9 plus 1 is 10, 7 and 1770. So since 354 is common between both the terms on the left hand side, I can factor that out, and I'm left with m plus n within brackets, and that should equal 1770. And if I divide both sides by 354, I get m plus n equals to 1770 divided by 354, and 354 goes into 1775 times. So what I am left with is m plus n is equal to 5. So I'll just write that here for the moment. M plus n is equal to 5, and then let me erase all this, and what I'll try and do is that instead of finding the sum, I'll find the difference between both these. So if I subtract equation number 2 from equation number 1, what I get is 221m minus 133m, that gives me negative 88m, and this will also become minus, so 221 minus 133 is going to give me positive 88n, and that should give me a difference of 88. So again I've got 88 on the left hand side, which I can factor out. So instead of 88, I'll take minus 88 as the factor, and this will become m minus n then within brackets, and that should be equal to 88. Then I divide both sides by negative 88, so that becomes m minus n is equal to 88 over negative 88, and then that simplifies to give me negative 1. So the second equation that I've got is m minus n is equal to negative 1. Now you can see how easy it is to try and solve these. So let me call this equation number 3 and this as equation number 4. Now just by looking at these, I know that the coefficients are same. So if I just add these two equations together, I can eliminate one variable and find the value of the other variable. So I'll just add these together. So m plus m gives me 2m, plus n and minus n, they get cancelled, so I don't need to write anything, and 5 plus negative 1 gives me 4. Dividing both sides of the equation by 2, I get m is equal to 2. So that's my value for m, and let me highlight that. And then let's try and find the value of n now. So to find the value of n, we can plug this value of m into any one of the equations above. So instead of going into 1 and 2, because they are very large numbers, since we have simplified those equations to equation 3 and 4, I'll just try and substitute these values into any one of the equations out of 3 and 4. So let me put it back into equation number 3. So I get 2 plus n is equal to 5. So subtracting both sides, subtracting 2 from both sides of the equation, I'm left with n on the left hand side, and it becomes 5 minus 2 on the right, which means the value of n that I get is 3. So again, that's my solution for m. We have for n, we have the values of both m and n now, and we can write that as an ordered pair if we want. The value of m is 2 and the value of n is 3. And you can we have already verified it, but if you want, you can put these values of m and n back into equations 1 and 2, and you'll find that they satisfy both the equations. So this is the solution. In case you have any questions, I would like to hear about it. Please leave your comments in the comment section below, because I'm waiting to hear how did you find it. Do you still find it tough? Do you find it easy? How did this video help you? I want to know all about it, so please leave your comments in the comment section below. If you like this video, and if you like the other videos that we have made, you should share these videos with your friends, because you have learned a lot out of these videos, and why should they miss out on all the fun? They should also try and learn something from these great videos that we have. And please refer these videos or share these videos with your friend. And in case you still haven't subscribed to the channel, then you press the subscribe button right here and subscribe to it right now, and do not forget to press the bell notification so that you don't miss out on any of our great content. You can watch these videos on the left as your next videos, and take care. God bless.